You know, OpenAI's O1 has got everybody talking. It's almost like it can reason like a human expert, tackling these really complicated problems that used to stump even the most advanced AI. And I get it. You want to figure out how it works, especially the whole reinforcement learning angle, right?
Yeah, it's like we're trying to crack the code of AI's next big leap.
Totally. And while OpenAI is keeping the specifics of O1 under wraps, there's this research paper called Scaling of Search and Learning, a roadmap to reproduce O1 from reinforcement learning perspective. It's like a blueprint suggesting we might be able to build something similar to O1 using reinforcement learning.
Yeah, the authors of the paper lay out a roadmap with four main parts: policy initialization, reward design, search, and learning. Each one is really important for understanding how an AI like this can do such incredible things.
So let's break it down, starting with policy initialization. I know it's technical, but is it kind of like giving the AI a head start in thinking like a human?
That's a good way to put it. It's about setting the AI up to approach problems more like a person would. This can make the learning process way more efficient.
But the paper doesn't really say how to do this initial human-like thinking, does it? It's kind of like a black box.
True. The authors say it's important, but they don't get into the specifics. They suggest the goal is to give the AI some initial policies that help it to reason and solve problems better.
So what could those techniques be? Are we talking about like mimicking the human brain? Or is it something else entirely?
There are a bunch of things researchers are looking into. One promising method is imitation learning, where the AI learns by watching and copying human experts. Another is using pre-trained models. These are AI systems that have already learned a ton of information. From huge data sets that can be a base for building more specialized systems like O1.
So it's like giving the AI a crash course in human expertise before setting it loose on a problem.
Precisely. By giving the AI this foundation, researchers can speed up the learning process and help the AI develop more human-like reasoning.
This leads us to the next part of the roadmap reward design. It sounds pretty straightforward. But how do we even define rewards when we're talking about teaching AI?
Think of it as feedback that guides how the AI learns, just like we learn from positive and negative reinforcement. AI learns by getting rewards for actions that lead to good outcomes.
So defining what good looks like for the AI, and then rewarding it when it gets there, makes sense. But isn't it hard to define those rewards, especially for really complex tasks?
You've hit on a big challenge in reinforcement learning. Designing good reward functions is a real art and a science. If the rewards are too simple, the AI might find loopholes and exploit them without really learning. But if the rewards are too complex, the AI might not be able to learn anything.
Sounds like a delicate balancing act. The paper mentions reward shaping and reward modeling. What's the difference?
Reward shaping is about breaking down a complex task into smaller steps and rewarding the AI for reaching each one. Like if you're teaching a dog a new trick, you wouldn't expect it to learn the whole thing at once. You'd break it down. Reward the dog for each step along the way.
So like creating a path with milestones, encouraging the AI to move toward the final goal.
Exactly. It's a way to give the AI more frequent and helpful feedback, which really speeds up learning.
And what about reward modeling? How does that work?
Reward modeling is a little fancier. We trade a separate AI a reward model to figure out what a good reward should be in a specific situation.
So like an AI coach, that gives feedback tailored to the AI's performance.
Precisely. This reward model learns from human demonstrations or other reward functions. It uses this to give more dynamic and nuanced rewards, to guide the AI to more sophisticated behavior.
Fascinating. It seems like reward modeling could be key for scaling reinforcement learning, so it can handle even more complex tasks.
Absolutely. As AIs get more capable, their reward structures need to be more complex too. Reward modeling is a way to automate and refine the reward design process, so it can scale and adapt.
Okay, so we've covered policy initialization and reward design. Let's talk about the next step search. I get the general idea, but how does an AI actually search for solutions?
Imagine you're playing chess. Every move you make, you have to consider tons of options and think about what might happen. When an AI faces a problem, it has to explore a huge search space of possible solutions.
So it's not just about number crunching, it's about strategically navigating a really complicated web of possibilities.
Exactly. The AI uses algorithms to search through this space, checking out different options and picking the best ones. The more computational power it has, the more options it can explore, which can lead to better solutions.
It's like having a more powerful flashlight to see in the dark.
That's a good way to put it. And the efficiency of the search is super important. The paper emphasizes how important it is to have sophisticated algorithms and heuristics. to guide the AI so it doesn't get lost in the huge search space.
So it's not just about brute force, it's about being smart about the search.
Exactly. Researchers have come up with clever techniques to make searching more efficient, so AI can solve really complex problems in a reasonable amount of time.
Okay, so the AI searches through all these possibilities, guided by its reward function and these algorithms, but how does it actually learn from this? That's the last part of the roadmap, right?
Yes. Learning is where the AI uses the data from its searches to improve. At the core of this are the AI's parameters. Think of them like the controls that determine how it behaves.
So it's basically tweaking its own internal settings based on what it's experienced.
That's right, through training. The AI adjusts these parameters to better match its actions with the desired outcomes, which are set by the reward function. The more data it has, and the more parameters it can adjust, the more complex and sophisticated its behavior becomes.
And this brings us back to scaling right. More data, more parameters, more computational power. It all helps the AI learn and solve harder and harder problems.
Absolutely. It's like a cycle where the AI's ability to search and learn fuels its own growth.
Yeah.
It's really quite fascinating.
Yeah.
It really is. It's a huge accomplishment for the researchers, pushing the limits of AI.
The paper also talks about these open source efforts to recreate. That really caught my eye. What do you think about that?
I think it shows how AI research is changing, moving away from closed doors towards more open collaboration.
It's like the AI community saying, let's work together on this.
Exactly. Open source projects let anyone with the skills contribute. It's making AI research more accessible.
It makes you wonder what'll come out of this open source world. Think we'll see more breakthroughs with so many people working together.
It's definitely possible. When you break down barriers and encourage collaboration, you create the perfect environment for new ideas. We might see AI technology evolve much faster.
That's exciting. Let's go back to something you mentioned earlier about the efficiency of search algorithms. What makes a search algorithm efficient in AI?
It's all about finding the best solutions quickly, without wasting time and resources on dead ends. Imagine you're looking for a specific book in a library. An efficient search strategy helps you find it fast, without looking at every single shelf.
So like a librarian who knows exactly where to go.
Exactly. And AI-efficient search algorithms use techniques to narrow down the search space. They get rid of paths that aren't going to work and focus on areas that will probably lead to good solutions.
Can you give me an example?
Sure. One common technique is called heuristic search. Heuristics are like rules of thumb that help the AI estimate how good a search path is. For example, in a chess-playing AI, a heuristic might guess how strong a board position is, based on things like material advantage or controlled important squares.
So using specific knowledge to guide the search.
Exactly. By using these heuristics, AI systems can avoid exploring useless paths, making the search much more efficient.
Interesting. This makes me think about policy initialization, that initial setup to help the AI think like a human. Do you think the search algorithm could also play a role in how the AI reasons?
That's a good question. The search algorithm definitely influences how the AI learns and explores. Different algorithms might lead to different problem-solving strategies, which could affect its reasoning abilities.
It's like giving the AI different tools to navigate its world.
Exactly. The tools we use shape how we think and solve problems. In the same way, the search algorithm might influence the AI's cognitive processes.
Let's switch gears. Let's talk about the data that the AI learns from. We've said that more data usually means better performance, but is there a limit to how much data an AI can actually handle?
That's something researchers are still figuring out. More data is generally good. But there are practical limits to how much an AI can process. There's a point where adding more data doesn't make much difference.
So it's not just about having a ton of data, it's about having the right data.
Exactly. The quality and relevance of the data is super important. Giving the AI irrelevant or noisy data can actually make it worse. Researchers are working on ways to clean and filter data to make sure the AI is learning from the best examples.
Like the saying, garbage in, garbage out.
Exactly. The same idea applies to AI. The quality of the data directly affects how well the AI learns and how well it can adapt to new situations.
Speaking of adapting, that's a big challenge in AI, isn't it? We want AI that can not only solve specific problems, but also use what they've learned in new situations.
Absolutely. That ability to generalize is what makes a truly intelligent system. It's not just about remembering patterns, it's about understanding the underlying principles and using them in new contexts.
And how do we get AI to do that? Is it just data and training, or are there other things involved?
Data and training are definitely key.
Yeah.
But researchers are also looking at things like transfer learning, where an AI trained on one task can use that knowledge for a different but similar task. This can help it learn faster and generalize better.
It's like learning to ride a bike and then using that to learn how to ride a motorcycle.
Exactly. Transfer learning lets the AI use what it already knows to tackle new challenges more effectively.
We've covered a lot. We've talked about the 4 main parts of the O1 roadmap: policy initialization, reward design, search, and learning. We've also discussed the importance of efficient algorithms, data quality, and generalization. What are your main takeaways from all of this?
I think the biggest takeaway is how complex it is to build an AI like O1. It's not just about using more data and processing power. It's about carefully designing how the AI learns, shaping its rewards, guiding its search, and making sure it can apply its knowledge to new situations.
It's like a symphony, all these different parts working together.
Exactly. It shows how creative and innovative the researchers are.
Yeah.
It's amazing what they've been able to achieve.
Stepping back from the technical stuff for a second, this whole idea of recreating O1 open source, it brings up some interesting thoughts. What really stands out to you about that?
It's the potential impact on access to advanced AI. Traditionally, cutting-edge research was limited to well-funded labs and big tech companies. But with these open source projects, the barriers are much lower.
It's like opening up a huge lab and letting anyone with the skills contribute.
Exactly. This open approach could lead to a burst of creativity. Imagine talented people from all over the world working together, sharing ideas, and pushing the limits of what's possible with AI.
It reminds me of the early internet, where that spirit of open collaboration led to so much progress.
It's a great analogy. That same spirit is driving AI now. It's really exciting. We can see a ton of new applications, solutions to problems we've had for ages, maybe even entirely new areas of AI research.
It's like planting seeds and watching a whole ecosystem grow. But with this increased access, some people might be worried about misuse. Do you see any risks with making these powerful AI tools more available?
It's a legitimate concern. Any powerful technology can be misused. But I think the benefits of open collaboration outweigh the risks. By making these tools more accessible, we can encourage responsible development, transparency, and ethical considerations.
Like a system of checks and balances, with a diverse group making sure the technology is used for good.
Exactly. With more people involved, we can better identify and address potential problems. So AI advancements benefit everyone.
So we've looked at how O1 works, the roadmap to recreate it, and the possibilities of open source AI. But as we go deeper into this world of advanced AI, we have to ask ourselves, what does this mean for the future?
That's the big question, isn't it? We're at a turning point in AI where these systems can do things that we once thought only humans could do.
It's like we're entering a new era, where the line between human and artificial intelligence is blurring.
And as we move forward, we need to have conversations about what these advancements mean. How will they change industries, our societies, our understanding of what it means to be human?
Those are big questions, and there aren't any easy answers. But by talking about them, thinking critically, we can shape the future of AI in a way that benefits everyone.
I completely agree. The future of AI is not set in stone. We create it together through our choices, our actions, and our commitment to responsible innovation.
Well said. This deep dive into O1 has been fascinating, exploring reinforcement learning, the power of scaling, and the potential of open source collaboration. As we wrap up, I'm feeling a sense of wonder and a lot of curiosity about what's next.
That's the best part. We're at the beginning of something amazing.
And on that note, we'll leave you with this thought. If AI can learn to think like a human expert, what does that mean for human expertise? It's something to think about as we move forward. Keep exploring, keep learning, and keep asking the important questions. Until next time, happy diving.